So problem 9 tells us that we have two urns. Now one of them is white. Let's draw these. So we have one white urn, and in this white urn we have two white balls and one red ball. And we also have another urn. We have a red urn, and in this red urn there's one white and three red balls. And then here's the experiment. What we're going to do is this. We're going to, out of this white urn, we're going to randomly select one of these balls, and we're not going to replace it. So if we get a white ball, then in the second trial, we'll choose out of the white urn again. If we get a red ball, now we'll go over and choose out of the red urn. And what we want to know, all in all, is this. What is the probability that we get a red ball on the second draw? So this is a good problem for using tree diagrams because we have something going in sequence. So let's start our tree here. So at first, we're going to draw out of the white urn. That's what we're told. And if we draw the white urn, we can either get a white ball or a red ball. Now, the probability of getting a white ball in the white urn, there's two whites and one red, so there's three balls altogether. So this is going to be 2/3 white probability and 1/3 red. Now, you know, these numbers here are going to have to add up to 1 because we have to either get a white or a red. And then in the second draw, here's what could happen. Suppose that we first, we draw a white ball. So we're in the white urn, we draw a white ball. Now what could happen is this. But now, if we had chosen out of the white urn, if we had chosen a red ball, we take that out and then we come over here and we draw out of the red urn. So what could happen? We could either get let's try that again. We could either get a white ball or a red ball. And now there's one white ball in here, right? There's one white and three red. So there's four balls altogether. One of them is white and three of them are red. So 3/4 for red. And we want to know what is the probability of getting a red ball on the second. We'll just follow these branches. How can we get a red ball on the second? We could get a white on the first, a red on the second. So this would do it right here. Or we could get a red on the second, a red on the first draw, and a red on the second. So that would be this node right down here. So how do we get here? We have to go here and here, so that probability is going to be 2/3 times 1/2. Write as and because it's here and here, so it's a multiplication. Or we could go this way, here and here. So that probability is going to be 1/3 times 3/4. Now, when I add these two products together, I got I'll do it down here, 5/833. Turns out to be 7/12. In problem number 13, we're told that 20% of the library books in fiction are worn and need replacement, and 10% of non-fictions are worn and replacement. Now, the library holdings are 40% fiction and 60% non-fiction. Use a tree diagram. So a question here might be this. I'm going to draw a tree. Which one do I do? Do I do this one, where I do fiction first, non-fiction, and then we say that they're, I don't know how should we say this, they need replacement or they don't need replacement. They need replacement. They don't need replacement. Or do I draw this tree? They need replacement and they don't need replacement, and then I go here to fiction or non-fiction, same thing down here, fiction, non-fiction. So how do I know which tree is going to be? Do I go with fiction first, non-fiction, and then replacements, or do I do replacements and then fiction, non-fiction? Here's how you're going to tell. One of them is going to give you numbers, the other one's not. Suppose that I try this one over here. So worn and replacement, I need replacement. So what number is that? Well, see, this number depends on if I'm dealing with fiction or non-fiction. I don't know what number to put here. So this is not going to be it. If I don't know what number to put here, it's probably not going to be this diagram here. But if we go over to this diagram here, we know what to put here. 40% of the books are fiction. And then we're told that 60% are nonfiction. And then the problem goes on to tell us that if it's a fiction book, if it's fiction, then 20% of those need replacement, so it must be that 80% don't. And if it's nonfiction, right, if it's nonfiction, we're told these numbers. That if it's nonfiction, that 10% are worn and need replacement. That must mean 90% are not worn and don't need replacement. And what we're asked for here is if you randomly select a book from this library, what's the probability that the book chosen from this library is worn and needs replacement? So what's the probability that this book needs to be replaced? Well, this book is going to need replaced right here if it's fiction and needs replaced. So we're going to choose that one. But it could also get replaced from this down here, this branch and this branch, nonfiction and needs replaced. So that's going to come right from here. Okay, then, so let's get these probabilities. You know what, let's erase this since we don't need that one anymore. That's not going to help us. So what we need now is this. We want this branch, which is 0.40 times 0.20, plus this branch here, which is 0.60 times 0.10. And when I multiplied those together and then added, I got 0.14.